Hey everybody, Mr. Gibson here. So I'm recording my own demonstration video for you today to introduce the idea of ionic compounds. So far we've learned about ions, how metals will lose electrons to become like noble gases. When they lose electrons, they get a positive charge. We've talked about how non-metals will gain electrons to be like the next nearest noble gas on the periodic table. Because they gain electrons, they have a negative charge. Now in 4.2, what we're getting ready to talk about is what happens when a positive ion and a negative ion bond together, or what happens when a cation and an anion bond together. What happens is we get what's called an ionic compound, okay? And you are surrounded by these things. There's a whole bunch of them in your body. You just may not have known that they were called ionic compounds. So for this activity, I really just wanted to kind of pique your interest about the characteristics of ionic compounds, okay? So I want to ask you a question real quick. Does water conduct electricity? I'll give you a second to think about that. Does water conduct electricity? And I don't go and Google this because I don't want any spoilers, okay? Just think about your own prior knowledge, your own experience, maybe what you've seen on movies and TV. Does water conduct electricity? Okay, well, we're getting ready to find out. So I want to show you what I've got up here. I've got a light bulb. Okay, I'm going to come to the camera and show you. I've got a light bulb that plugs in like most lights do, and it's got two prongs. Now the circuit on this light bulb is not complete unless electricity can flow between the two prongs. So right now, if I were to plug this in, nothing would happen, okay? So if water conducts electricity, I'm going to put this inside of a beaker of water, and if it conducts electricity, then the light bulb will turn on because electricity can flow between the two prongs. Okay, now let me show you this. This is the water. This is distilled water I got from down the hallway, like where everyone fills up their water bottles, okay? So this is pure H2O right here, okay? Just no tricks, no magic tricks right here. I just wanted to show you what we've got going on. All right, so what I'm gonna do is I'm gonna put the light bulb into the water, and I'm gonna plug it in. And if water conducts electricity, that light bulb will light up. Okay, 3, 2, 1. And nothing happened. So water is not conducting electricity. That's interesting, right? That probably goes against what your prior thoughts might have been. Now, let me see if I can make this water conduct electricity. What I've got right here is salt. Believe it or not, table salt, sodium chloride, is an ionic compound, okay? Sodium is the cation and chloride is the anion. When you put them together, you get sodium chloride, an ionic compound. Actually, a name for all ionic compounds is salts. So we use salt to just talk about sodium chloride, but it can actually refer to any ionic compound. Now, I'm going to try to do this smoothly. I'm going to leave the light bulb in the water. Notice it's not on. And I'm going to start pouring salt into the water, and you let me know if you notice anything. Actually, you can't let me know because you're watching the video, but just try and notice something. Okay, there's some salt. Notice anything? The light bulb is lighting up. That is a big, very important characteristic of ionic compounds, is that they conduct electricity when dissolved in water. The water doesn't conduct electricity. It's what's called a covalent compound. It's just hydrogen and oxygen, two nonmetals. But when you have an ionic compound, that's what conducts electricity within the water. Okay, so big important characteristic of ionic compounds there. Now, don't recreate that at home because we have this kind of special apparatus set up so that it's safe for me. Don't go like trying to like throw your microwave in a pool or something like that, because it's not safe. Because most water still has ions in it. I used pure water, but tap water still has ions, so it actually will conduct electricity. So just be very careful. Like I said, don't recreate this outside of a lab in which I'm in that lab, okay? Now, I wanted to show you this just for fun. You know what else is chock full of water and ionic compounds? A pickle. Let me show you the pickle. Here you've got a pickle, okay? Pickles are full of water. Okay, if I were to squeeze this, all the pickle juice would come running out, and it's full of salt. They're really salty and briny. So let's see if we can conduct electricity through this pickle. So I've got the pickle. I'm gonna put it on this paper towel just for not making a mess. I'm actually going to have the light bulb again, and I'm going to plug it in. Now I'm going to stick the prongs down into the pickle, and if the pickle conducts electricity, then the light bulb will light up. So let's see what happens. 3, 2, 1. Whew. I got some sparks there. And there we go. We are lighting up a light bulb with a pickle. Again, don't recreate this at home. It's not safe, but it is cool to see on a video and in a chemistry demonstration. So we learned a little bit about ionic compounds today. They conduct electricity when dissolved in water. If you guys have any questions about that or about the assignment, feel free to email me. All right, guys, thanks.